I was intending this week to go a little bit further into one of the subjects we're discussing with our solid code principles, and specifically the Liskov substitution principle, and look at the idea of covariance. But when I was thinking about how to explain it, I realised I'd have to talk about the IEnumerable interface, and I actually discover when I'm teaching that quite a lot of people don't really fully understand the IEnumerable interface. So I was going to tell you about that, and then I thought in order to understand IEnumerable, you've got to understand a fundamental C# language feature, which is explicit interface implementation. And once again, quite often people haven't come across this. So actually that's what I'm going to be looking at this week, explicit interface implementation. And then in the next video it'll be IEnumerable, and the video after that it will be covariance. So we will get there in the end. If you're already familiar with this, then have a little break and move on to the next video. But what I wanted to tell you about was this idea of explicit interfaces. So let's take a look at this in code. And what I'm going to do is show you this in a slightly artificial way and then a more practical example. But just to deal with interfaces firstly, let's suppose that here I just wanted to write a class. So I'm going to, in here, just put public class, some class, and then just as an example interface, I'm going to make this clonable. And something that you should be familiar with in Visual Studio is if you've got an interface, you can hover over it, click on Implement Interface, and it will give you an empty stub with a not implemented exception for all of the methods, just one in this case, but all of the methods in the interface. And you could have typed that for yourself, but it's just a little helper there. But something that you may have noticed is we've also got this option of implement interface explicitly. And so that's what I was going to tell you about. So let's have a look at an example. As I say, this isn't entirely realistic, but it does show the basic idea. And what I'm going to do is in here, I'm going to just declare a public interface called iWindow. So this is part of some kind of windowing system, some kind of desktop GUI. And although I'm just plonking it here straight into the same file as program, it would probably be in a completely different package, a completely different library. And obviously this could have lots and lots of methods, but I'm just going to give it the one method, close. And obviously what we mean by closing a window is we want to shut it down, not display it on the screen anymore. But then let's suppose in a completely different package, we had an interface called iBankAccount. And once again, amongst the many methods that might have, it could also have a method called close. Now, clearly, closing a bank account is a completely different concept from closing a window. Closing a bank account means removing all the funds, closing it down completely, not having access to it anymore. And really, it's just a quirk of the English language that the word close is used in both cases for these two utterly different meanings. Now, obviously, if these were being designed side by the same author, you might be a bit careful of this. But we're saying these come from completely different packages. There can't be any negotiation between the authors of the two. Now, for the most part, things will be fine. But if I were to actually have something like this, if I had a class, and let's call this banking dialog, and if I were then to say iBankAccount, iWindow, so because this is a banking dialog, it implements both the window interface and the bank account interface, then we have a bit of a problem. Because if I simply type that in there, or if I go for the code generation of just implement interface, we can see there's no errors on either interface anymore, but we've only got the one close method. And what's happening here is that close method is implementing close in both the interfaces. So the one method is both the window close and the bank account close. And that's a big problem, because what do you do when we've established that closing a bank account and closing a window are such completely different things? And in fact, in a lot of languages, certainly in C++, as far as I know in Java as yet, unless they've changed it recently, there's no real way to fix this. You just can't mix these two interfaces if they have methods with the same name, the same parameter list, but with different meaning. In VB, they have solved this in a slightly different way to C#, basically the same principle, but we're going to look at how it's solved in C#. Because what we actually do is we don't implement the interface, we implement the interface explicitly. And we do that separately on each one of the interfaces that has the ambiguous method. So here we can see what it's generated. Obviously I could have written that directly, but the code generator is easier. But what it does is it disambiguates the two clauses by preceding them with the name of the interface followed by a dot. So now we have two explicit implementations, each clearly tied to a particular interface. And then what I'll do here on this one, I'll simply, in this case, state what's happening. So we'll just put that into the right line, and on the other one, I will make it clear what's going on again. So clearly different operations there. And then in main, let's create ourselves a banking dialog. Let's say banking dialog BD equals new banking dialog. And then let's say BD.close. And lo and behold, it's not there. And it's not just IntelliSense that thinks it's not there. If we try and build that, then the compiler is going to tell us it's not there. And actually, if we look at how that explicit implementation has been done, we've got a clue as to why, because neither of these methods has been declared as public. In fact, when you're doing this explicit implementation, you don't declare them as anything at all in terms of public or private. They're in a separate state of their own. Because in order to access one of these methods, we have to access it through the appropriate interface. So I could say something like this, iWindow W equals BD. And that assignment is perfectly valid because remember, we're allowed to take a variable of an interface type and assign into it any object that implements that interface. But now, of course, if we do W dot, we can see we do have the close, and you will be unsurprised to discover that that is the close for a window. So when we run that, we can see we're getting iWindow.close. And if I were to approach that the other way, if I were to say iBankAccount BA equals BD, and then say BA.close, then the second time around, we get iBankAccount.close. So we've disambiguated the two methods within the class itself, and then to access one or the other, we have to go through the appropriate interface. Now in practice, although occasionally it happens, it's quite unlikely that you put it into the interface in quite such an obvious way as that. More usually, it would be the case that you had a method. So if here we have static void, and then let's say process window. So that's going to take an iWindow and call w.close. And so in that case, obviously enough, if we just pass in our banking dialog into process window, it picks it up as an iWindow interface, and so we get the iWindow.close. So really neat idea, just a way to solve this problem. It's a relatively rare problem to occur, but when it does occur, in those languages that don't have this feature, it's really just absolutely catastrophic. Whereas in C# we have this approach, we can disambiguate it. One other thing we can do actually, if you've got multiple interfaces with the same method, a maximum of one of them can be implemented implicitly. So if we say decided that the more obvious one in this case is to close the window, then what we'd actually do is take off the iWindow dot and make that public. And so now that's the implicit implementation, the one that doesn't mention the interface it comes from. And then however many others we have, in this case just one, they have to be explicit. And so now what will happen is we can say bd.close. And if we say bd.close, it will be the close for the window. And if we want to get at the other one, then we've got to say our iBankAccount BA equals BD. And then we can get at that through the interface. So up to you what you do, but obviously the thing you probably don't want to do is implement a method from two interfaces with the same implementation, because it's very rare that they actually mean the same thing. As I said, that's a little bit of an artificial example, but what I'm going to show you now is actually a situation fairly recently where I hit this when I was doing the turtle graphics that you may remember from the video on the interface segregation principle. So if we look in here, you'll see I've got a WinForms application called Turtle Display, and then I've got this Turtle Logic. And in Turtle Logic, we have an interface called iTurtle. So if you remember what I was saying about Turtle Graphics, very simple. You simply move the pen up or down, and if it's down, it's touching the paper. And then when you move, if the pen's down, it will draw a line. If not, you just move to the location. So that's what we've got there. And then what I had was a number of these shapes, like for example a circle, which take this iTurtle interface as a parameter and then move to a start point, put the pen down, and then in that case draw a circle, and we've got other ones as well. Now, slightly different from what we did this in the previous video on the interface segregation principle, I want to actually implement this iTurtle directly in my turtle form. So I want to actually on here put in the interface there, and then you can see that on things like my draw circle, I've created the circle object, and then into that draw I'm trying to pass this, which at the moment won't work because we haven't implemented the interface. So let's go on and do that. So on here, after the base class form, I'm going to say comma iTurtle. And remember that we've got the three methods in there. So let's actually type these in. We had our public void up. And so to make that work, let's actually put in a private bool called pen down. And so when we go up, we're going to say pen down equals false. So I could have done this obviously with the code generator, but I just wanted to do it manually so we can see the process. And then we have down, which is going to set pen down to true. And then the other one, we were going to have a public void move double x double y. And what I'm going to need for this is I'm going to put in a private tuple. So we're going to call this double x double y, and I'm going to call that last point. So the last point we went to. And then in the move, what I want to do is actually I'm going to say if pen down, so if we're drawing, then I'm going to actually call this method that I've called staggered draw. And this is just there to make it so the line isn't drawn in one go, it's drawn in a number of steps just to move like the turtle moving across the page. So what I'm going to do is, if the pen's down, then I'm going to say staggered draw to that location. And then, regardless of whether it's up or down, I'm going to say that last point is a new location, x and y. So we only draw if the pen's down, but we always move to the new location. The details of that don't matter. What matters is we're getting this warning on move. And what it's saying is move hides the inherited member control.move. So this is slightly different. We've not got two interfaces. What we've actually got is in the form, we've already got something called move defined. The move is actually the event that happens when the form is moved, whereas in the case of the interface, obviously it's us wanting to move the turtle to a particular point. And so we get this clash that needs to be resolved. And actually, if I just comment all of these out and then go back and do what I'd more normally do, which is go for this implement interface, notice I'm going for implement interface, not implement interface explicitly. And what it's done is, because there was no problem on up and down, it's just done the implicit implementation, but because there was a problem on move, it's done the explicit implementation, so we won't get confused. So actually all we need to do is take the functionality I'd already written and pop that in there. But quite often, as you can see, we don't have to worry for ourselves whether we need to do it explicitly or implicitly, because if we're in a situation where we do need to do it explicitly, that just happens automatically when we use the Visual Studio tool to implement the interface. So there we've got our move, and now it's no longer clashing with the existing move event that we have in our form. And so now, if I just uncomment all of these, we can see they're now happy. And again, we can see this situation when we go to, say, our squares draw, and it calls move. Now there's absolutely no ambiguity, because that move must be the move for the turtle, because that's all we've got in here. We've got no idea that there's a form involved. We can only see the three methods on the turtle. So it does slightly relate to the interface segregation principle in that by keeping our interface tidy and isolated, we avoid these name clashes. So if we just set that as the startup project, and run it, then we can see that our various commands are now working. So there we've got a situation where we've got a genuine need for explicit interface implementation. The example with the iWindow and the iBank account made it clear what was happening, but it was a little bit artificial. But there was a real situation where just because you happen to have an interface with the name move in it, it clashed with an existing base class, and we had to use this feature. I said this was related to IEnumerable, so let's just look quickly at that. Let's go back into our console application, and let's just suppose we have some class here. So let's just have a class some collection, because that's what IEnumerable is used for. And if I were to make this an IEnumerable is a generic, let's make an IEnumerable of int, doesn't really matter. But if we just take a look at the definition of IEnumerable, we can see IEnumerable has this get enumerator, but also the IEnumerable generic interface with the angle brackets is derived from this non-generic IEnumerable. And this is here for historical reasons, because generics only came in with version 2 of C#, back with Visual Studio 2005. So it's going back into history, but for backwards compatibility reasons, we still have to have the non-generic IEnumerable. And the problem is that also has a slightly different get enumerator. So in this case, we're picking up two methods with the same name, not through two separate channels of interface implementation, but because of inheritance, where actually there's no way around it. If we're going to use the generic IEnumerable, we've got to use the non-generic. And so what that means is, if I, again, just do the implement interface, it gives us both the generic version and the non-generic version. And as I was saying, because the generic version nowadays is by far the most common, that's the one that it does implicitly, and the one that's just there really for backwards compatibility is done explicitly. So that was it, a quick look at explicit interface implementation in C#, which will lead us on to seeing IEnumerable, which we'll be doing next time. Hope you enjoyed that. Any questions, put them in the comments section below, and please do subscribe so that you won't miss any future updates.